Okay, hello everyone. I hope you all are fine. So today we are going to learn about the natural language processing part 1. Let me know, am I audible? Am I clear? Is the screen visible? Please let me know. Anyone can write a chat. Are you able to write it? So sir, guys, we are going to start with the introduction to the NLP. Let me start with the introduction to the NLP, why we need NLP. If we talk about the communication, if we talk about the normal communication with the computers. Earlier, in the basic of the structure, we had low-level language. We had low-level language. Low-level languages were written in zeros and ones. This is how the low-level languages were written. It was directly understood by the computers. These instructions written in binary language are directly understood by the computers. But they were very difficult. They were very difficult to write. So then we came into the era of high level language. High level language means Python, C, C++, and Java, and so on. These kind of language were written in English language. But can computer understand the English language? No, definitely it will not be able to understand the English language because the computer is understanding only binary language. So for these language, we need a software called compiler. Okay, so compiler converts our high level language into the binary language. It converts, I will write here conversion. It converts the high level language into the binary language, and that binary language is understood by the computer. Okay, so this is the basic idea. This is the basic idea we are having. So now if we have the high level language, which is easy to learn as compared to the low level language, I will write here easy to write / learn. Now, if we already have the high level language for the communication with the computers, what is the NLP then? NLP is also the source of the communication between the user and the computer. But how? Just like I'm communicating with another person. As I'm right now communicating with you, as I just communicated with the Saurabh sir. So the communication was clear. So it was understandable from both of our sides. I want to make the computer having the same understanding. I want to interact with the computer. So now I will have the NLP case. I will make one line here so that I can or I will create it all. Now in the NLP case, I want to communicate with the computer with the English language directly, just like I'm communicating with a human. We can take the example of the NLP as the first example is Siri. Second example we can take is Alexa. The third example we can take it as Google Home. If we can take these three as options, giving them the instruction, it's not about the coding. It's not about the high level language and low level language. No, definitely not. Whenever we try to talk with the Siri, whenever we try to talk with the Alexa, whenever we try to talk with the Google Home, we talk with them in our normal language, that is English. So if the computers, they are also the computers, Siri, Alexa, Google Home, they are also the computers. But if they are computers and they are understandable only binary language, how they are understanding my English language? How they have built up that particular understanding? That understanding has built up by the help of NLP methods, that is natural language processing. Whenever we want to develop a system, whenever we want to develop a system which can understand human language directly, which can understand human language directly, that time we need to come across regarding the concepts of NLP. We need to use the concepts of natural language processing. I hope it's clear. So let's get back. Right now, if we see that a lot of data is unstructured data. Now, what is the difference between the structured data and unstructured data? Let me write that also. Let me get back to the screen. I hope this one is clear. So what does the unstructured and structured data mean? Let me write structured here. Structured data, unstructured data. Okay. Structured data and unstructured data. In the structured data, what we are having, our data is like this. In the structured data, our data is in tabular fashion. So I am making a table here. This can be ID. This can be another parameter such as I will take it as car color. This can be another parameter as engine size. This can be another parameter as fuel consumption. And this can be another parameter as CO2 emission. So if the data is like this, means in the rows and column wise, or I will say directly as in the table, then it's known as structured data. If the data is in tabular format, then it's known as structured data. But if we have data like this, text, audio, videos, images, then this is known as unstructured data. Then this is known as unstructured data. And right now, NLP works on this particular thing, text data. Text, unstructured data. The basics of the NLP that we need to first pre-process our text data. We need to pre-process our text data, and how we can do that. If we check the name of the NLP, it is known as NLP. At the end, we have the processing word in it, natural language processing. So even though our at the end goal is to make computer understand what a language is, how I am trying to communicate with another persons, I want to communicate same with you. Same way I want to communicate with you. But for that, I need to first make him understand. I need to first make the particular computer understand what is a text, how it can understand it. Right now, I am trying to communicate with you through English language. You are able to understand me, and I am able to speak because we both know about the English language. Same thing is here. If I want my computer to learn, if I want my computer to understand the English language, the instructions in English language, then I need to teach my computer English language. And that process belongs to the natural language processing. that process belongs to the natural language processing. Okay, this is the first point. The second point is, if we talk about the current generation, in the current generation we might have seen that people always want easiness in their life. Every time people want to code, every time they want to give the instruction in terms of easiness only. Nobody wants to write the code for everything. So for that, again, we are choosing the NLP as an option. We are writing our code with by just talking. Okay, okay, just write print statement, then declare a variable. Like this, we are talking. So this is the example of where we need the NLP. If we now see the unstructured data examples, we are come across with the many things. But currently, we are going to deal with the text data only. So let's see what are the different pre-processing units are there in the NLP for the NLTK. So as I said in the second point, as you are able to see, a lot of data that could be analyzing is unstructured data. And it contains human readable text. Human readable text, suppose we are chatting with each other, we are messaging each other, I'm sending you SMS, you are replying me back as SMS. That is a text data. And the text data is always unstructured data. The computer cannot understand it directly. We need to do some processing before we need to use the data. So let's see what are the steps we need to follow. If we can see that if natural language processing refers to the way we humans communicate to each other. As I already said, the way I am communicating with you, I want to make the same communication development between the computer and me. So for that, what I am going to do, I am going to use the natural language processing. Where it's used? It's used in the science menus, email, SMS, web page, and many more. Many ways we have the text available in the form of signs, in the form of menus, in the form of emails, SMS, web page. If we see that every bit of our information is mostly contains the email text only. Now let's see the introduction to the NLTK. What is the NLTK? NLTK is a natural language toolkit. NLTK is a natural language toolkit. And in this toolkit, what we are having an API performance. API performance means that you are giving your one type of data from this side, you are giving your one type of data from this side to the API, and you are getting output. No extra code written. It's a very powerful tool for the ML models, for the machine learning models. Machine learning models understands only one type of data, that is structured data. But is our text right now structured data? No, they are not. So what we should do? We need to do like this. We need to pass this text to the NLP process. We need to pass this text to the NLP process, and we will get the output as structured data. And then we are going to feed this structured data to the ML model. This is how we are going to do it. Let me know, guys, is it clear till now? Any confusions? Okay. Now the first step of the natural language processing is tokenization. Tokenization means the breaking of the raw text into the small chunks. What does the breaking the raw text into the small chunks mean? So let me give you whiteboard. Let me clear this one. Suppose, guys, you are going to learn a particular new language. new language, you are going to learn about Japanese, or you are going to learn about the Espanol, you are going to learn about the French. There are many languages available in the world. Now, do you directly learn about the sentences, the paragraphs, or anything, or you will start with a word by word thing? So your steps will be what, right? While learning to the new language, your steps will be: first step, learning by words. It will be learning by words. You cannot learn directly the paragraphs. You cannot learn directly the sentences. You need to start with the words. So if we want to train our desktop, our laptop, our any machine, our computer for a particular language, do we expect that that particular machine will directly learn on sentences? No. That particular machine should be also trained in these steps only. So what is the first step? I need to train it based on the words. But my input is in the sentence. But input is a sentence. So what I will do, I will break this sentence into the words. I will break this sentence into the word, and that particular process is known as tokenization. That process is known as tokenization. So what I am doing here, just like I understand words first, then I will learn the sentence. Same thing I am going to do here with the computer. Even though my input is in sentence, even though my input is in sentence, but what I am trying to do, I am breaking that particular sentence into the words, and that is known as tokenization. I hope it's clear. Tokenization is breaking the raw text into small chunks. I hope I made you understand this. Tokenization breaks the raw text into the words, sentence called tokens. Okay. So if we have the sentence like this: hello, my name is Ajay. If I have like this, so after tokenization, it will be like this: hello, my name is Ajay. It will be like this. Okay, so this is the use of the tokenization, breaking the sentence into the words. The tokenization helps in interpreting the meaning of the text by analyzing the sequence of words. So we are interpreting the meaning of the whole sentence by analyzing the sequence of words. Now let's see the tokenization by word. Firstly, so in order to tokenize words, or we can say them the atoms of the text. We can say them the atoms of the text. What we are doing, we will take that particular whole sentence, we will feed that to our word tokenize, and then we are going to break that into our words, or I can say atoms. The thing is how to do it. So this is the code snippet I need to follow. This particular code snippet I need to follow. The code snippet is I need to use from the NLTK. In the NLTK, there is another subclass that is known as tokenize. From that, I need to use the word tokenize. From that, I need to use the word tokenize. So let's see how we can do it in practicals. Let me share my Jupyter notebook to you. So guys, this is the natural language processing, and this is the first step we are doing. In the first step, what we are trying to do, we are trying to get the word tokenized into our Jupyter library. So how I am doing it, I am writing from NLTK dot tokenize. Means there's a big library as NLTK. There is a big library as NLTK. In the NLTK, we have another library as tokenize. And in the tokenize, I have the another library as word tokenize. So what I am doing here, NLTK, tokenize and word tokenize. So from NLTK dot tokenize, I am fetching this word tokenize. Same thing I am writing here. From NLTK dot tokenize, import means get the word tokenize. This is the word tokenize I'm getting. I hope it's clear. Then I'm making a string. In the string, I am writing it as hello, my name is Ajay and I am from ML department. Hello, my name is Ajay and I am from ML department. So it's a string, it's telling me hello, my name is Ajay and I am from ML department. So I'm checking this string here and the output is this. But if I am feeding this string to the word tokenize which I got from here, so I am writing word tokenize, brackets open, and I am passing the same string here. So what I am getting the list of words. See here, I am getting the list of words. My whole sentence got broke down into the words. It is taking hello as one word, my as one word, name is Ajay. Even though it's taking the point, stop word, it's taking as only as a word. I am from ML department. Then it's breaking this particular thing also, even though it's a smiley. It should take this as a one word. A smiley should be taken it as a one word, but it's breaking that also. This is the limitation. This is the limitation. And how we can overcome this limitation, we will see that also. Okay. So let's go back. I hope you understood the word tokenize. So this was all about the word tokenize. Now we have the tokenize by sentence. Suppose I have one paragraph and I want to break that paragraph into the sentences. I want to break that whole paragraph into the sentences. So what I will do, I will use the same process. I will use from NLTK dot tokenize import send tokenize. Send tokenize means sentence tokenize. And here my text is like this. Hello everyone. Welcome to InsideAIML. You are studying NLP. So this will be broken down like this. Hello everyone. Welcome to Inside AI ML. You are studying NLP. So this is the three sentence we will get. The first sentence is hello everyone. This will be the first sentence. The second sentence will be welcome to the InsideAIML. This will be the second sentence. And the third sentence will be you are studying NLP. And how it defines where the sentence end and where the sentence begins. It decides by this. By this, it decides that where to start and where to stop. Okay, so let's get to the practicals. See here, we have sentence tokenize here. I am doing the same thing from NLTK dot tokenize import send tokenize. So how can I do this? How can I justify this statement? There is an NLTK library Inside the NLTK library, we have sub-library as tokenize. In the tokenize, we have sub-library as send tokenize. So what I am writing from NLTK dot tokenize import sentence tokenize. I am giving my Python the proper path. I am giving the Python the proper path from where it will get this sentence tokenized. So I am telling my Python, firstly, you need to go to the NLTK, then you need to go inside to the tokenize. From tokenize, you will get the send tokenize and get that send tokenize. This is how I am doing it. Hope it's clear. Now I am having the same string. Hello, my name is Ajay. If we look at above, here is my string. Hello, my name is Ajay and I am from ML department. So it's a one sentence. See here. If I now let's see how it break into two sentences based on this one. See here, it got broke down into the two sentences. Hello, my name is Ajay. I am from ML department. I am from ML department. So the sentence got broke down into two things. So this is how sentence tokenize work. Earlier it was word tokenize. The division was based on the words. Now the division is based on the sentences. Now we have another thing that is known as tweet tokenize. Tweet tokenize means that whenever we have the tweets, there are very much chances that we have smileys in them. That time we have high chances that we have smileys in them. But if I pass this to the word tokenize, what will happen? The output will be like this. The output will be like this. But I want the word tokenized, but it should consider the sentence as one only. But it should consider the sentence as one only. So how can do that? I will use the tweet tokenize. Same process I need to follow. From NLTK.tokenize import tweet tokenize. But then the tweet tokenize is a class. Tweet tokenizer, it's a class. Let me show you. The tweet tokenizer, it's a class. It's not directly an object just like the sentence tokenize and word tokenize. It's a class. It's a template. So in order to use the functionality of the tweet tokenizer, what we are going to do, we are going to make the object of it. So we are creating the object of the tweet tokenizer. Okay. Now, after creating the object of the tweet tokenizer, now we can use the functionality of tweet tokenizer. Now I am writing TK, that is this particular object name, and the tokenized functionality, and I am passing the same string. So it is breaking right now. It is breaking my sentence into the words. But if you look at the end, the smiley, it's not breaking it. It's not breaking the smiley at all. It's keeping it as it is. Because it understands that the smiley has its own meaning. I hope the tokenization is clear for you. Now we have the stop words detection, a stop words removal. The stop words removal means that in our sentences, we have many things. We have a and the, it's, they, etc. Lot of things we have in our sentences, which are not required. For the machine learning and the NLP, those are the things which are not required. So, but our sentences mostly consist of those elements only. So what should we do that? We will use a stop words removal method. So in the stop words removal method, what we are going to do, we are going to remove all the unnecessary steps which is not required for the machine learning. Because ultimately, our motive is to feed this data to the machine learning model. As the use of these stop words is negligible, so carrying them to the modeling is not necessary at all. So we are going to remove these. If the sentence is having and, yeah, it's, they, all those words will be deleted. But we need to follow the paradigm. So what is the paradigm here? The paradigm is here that if we have a sentence, we need to firstly tokenize it. Then only we can use the stop word removal. Because stop word removal can be work on only words. It can work with only words. And how we can get the words? We can get the words by the help of tokenization. So if you have the sentence, you cannot directly apply the stop word removal. You need to firstly tokenize that particular sentence into the words. Tokenize into words, and then only you can use the stop word removal. So this is it. This is the code snippet, and this is what we are going to follow. Let's see. Firstly, I am importing the NLTK. I am importing whole NLTK library. Then I am importing these stop words. I am importing these stop words. After importing these stop words, I need to download those stop words. And right now I am using the English stop words. So I am writing stop words dot words English. Means English language stop words I am checking. So what are the stop words? These are the stop words. I, me, my, myself, we, are, ours, ourself, you are, those, am, is, during, before, after, only, on, say. These are all the stop words which are unnecessary. If your sentence is filled with these words, then you should remove these words from that particular sentence. You should keep only relevant information into that sentence. These words should be removed. I hope it's clear. Now the process I need to follow. What is the process? The process is I need to first tokenize my sentence, and then only I can use the stop word removal. The process is I need to apply the word tokenization first, and then only I can use a stop word removal. Let's see. Here I am using, firstly I am getting the stop words from the NLTK.corpus, and then I am importing the word tokenize. It's not necessary that I have wrote the stop words first and word tokenize back, but I can import this like this also. Firstly I will import word tokenize, then I will import the stop words. Then I am making a particular sentence. He is Ajay. He is a mentor of AIML. So I am checking this sentence. The output is he is Ajay. He is the mentor of AIML. Now I am checking what are the stop words. Stop words dot words English, and I am creating the set of it. Whatever words I am receiving from here, I will give you example. So I am, see here, this is a list. The output is a set of list I am getting, but I am converting these words as set. So I am telling my Python whatever the stop words are available in the English language. Whatever the stop words are available in the English language, store them into a set and give the variable as a name as stop words. Store them in the variable as stop words, and the data type should be, or data structure should be, set. Now I am checking my stop words. If I check the data type of my stop word, you can see that it's a set. You can see that it's a set. So this is the stop word. These are the stop words in my set right now. And if in my sentence anything is present which is present in the stop word, I need to remove that. Now I am my first job is to tokenize it. So I am writing word token. I'm making a variable as word token and I am using the word tokenize statement. In the word tokenized statement, I am passing this particular thing, that is except, means this particular sentence. I have displayed that here also. This except. What is except? He is Ajay. He is mentor of AI. Now I word tokenize it and I store that in word token. Now I am checking the word token. This is what I am getting. He is Ajay, comma, he is a mentor of AIML. Okay, so I broke the sentence into the words. Now I am creating a filtered sentence as an empty list. Now I am creating the filter center as the empty list. What I am doing here? I am writing a for loop and I am checking for W in word token. Word token is this. Let me go through one by one. For W in word token, what is the word token? This is the word token. So what will be the W value in the beginning? The W value in the beginning will be HE. He. This will be the W value. Then I am writing this particular condition. If W not in stop words, means what is the W right now? The W is he. If he is not present in the stop word, then this condition will be true. Let's see. Is he present in the stop words or not? He is here. So he is present in the stop words. Is our condition true or false now? Our condition here is false. Our condition here is false. Because I am saying that W, which is he now right now, not in stop words, but it is in stop words. So the condition is false. This particular statement will not be executed. Again, the execution will go back here. Now the W is. Let's check is present in the stop words or not. Is see here, guys, is this present? Again, is a stop word. So I am making my condition as my condition is W not in stop word, but is a stop word. W is currently is, and is a stop word. Again, the condition is false. Now W will be Ajay. It is no doubt, there is not a single doubt that Ajay cannot be a stop word because Ajay is a name. Name cannot be a stop word. So it will not be available in that list. So this particular condition is true now. This particular condition is true now. So I am writing filtered sentence, this particular list name that was empty earlier. Dot append. Append means insertion of that particular data. Which data? W. What is the W right now? W is Ajay. So Ajay value is getting inserted here. Ajay value is getting inserted here. Then W is comma. Again, comma is not there. Comma is getting inserted here. Then we have he. He is again a stop word. Again, this particular statement is false. Is again a stop word. Again, this particular statement false. Yeah, again a stop word. Again, this particular statement called for mentor. No, it's not a stop word. This particular statement will be true. Again, append W. Again, mentor came here. Of again stop word. This particular Statement false, again AIML now. AIML will be inserted to the append and AIML will be here. So now we got, earlier we had he is Ajay, comma, he is a mentor of AIML. But now our filtered sentence is which doesn't have any stop words in it. Ajay, mentor AIML. This is our relevant data. This is our relevant data. Any confusions, guys? Are you able to write the message on the chat? Do you want me to repeat any topic again? Anyone? Anyone can confirm it? I believe there is no questions. Okay. So this was all about the stop word removal. Now we have the stemming. Let's see what is stemming. In the stemming, we get the stems of each word. Machine learning computers are not interested in what our particular word is. They are considered as what is the particular stem word of it. Suppose plain, played, and played. They are not the stem words. What are the stem words for these three? It's play. This is a stem word. Work, working, worked, works. These are not the stem words. Stem words is work. Stem word is work. The computer, the machine learning, or the NLP, it is considered or it is concerned with the stem words only. These words. It doesn't consider about these things: playing, played, plays, working, worked, works. It is concerned with the last thing only, that is stem words. So how we can get the stem words? By the help of this stemming. By the help of this stemming formation. Let's see. So I am using right now again from NLTK .stem import Porter stemmer. Porter stemmer I am using. Porter stemmer I am using. So Porter stemmer is again a class, so I need to create an object of it, just like in the TE tokenizing. Now I have words as program, programs, programmers, and programming. Now what I am doing, I am writing a for loop. In the left hand side, I am writing a particular word, that is program right now. And I am writing a particular string here, stem it to, and I am stemming that, ps.stem. So first word is program, and when it's getting stemmed, it's program only. The second word is programs. When it's getting stemmed to, it is telling me program. The third word is programmers. When it's getting stemmed, it is getting output as program, but double M. So this is the problem with the stemming. The fourth one is programming, and it is getting stemmed to again program. So we are getting the stems of each word here. We are getting the stems of each word here. But our data was in the list format. Suppose our data is right now into the string format, means into a simple one string. What we need to do, we need to follow again our procedure. We need to firstly do the word tokenize. Means we need to break this whole string into the respective words. So with the help of word tokenize, I am getting this particular thing: play, playing, plays, play, but in the different units. This is another unit, another unit, another unit, another unit. Earlier this was the whole unit, But right now, this is 1 unit, this is 1 unit, this is 1 unit, this is 1 unit. And each token, each unit is known as token. Each unit is known as token. So now we have here for W in word token. For W in word token. Now I am doing again the same thing. W I am writing in the left hand side, and I am writing a particular string here, stem2, and here I am using the ps.stem method again, and I am passing this W, same W. I am getting the output as play, stem2 play, because play is the stem word. Then I am writing, then my second word is playing, stem2 play. Again, play is stem2 play. Again, played, stemmed, play. So we are getting stem words of this particular thing. We are not considered about the high level of the words. We are concerned about the stem of the words. Any confusions, guys, till here? So I will wait for 1 minute. If you have any questions, please write it down. Okay, no questions is seen. So let's get back to the PPT. Stemming is clear. Application of stemming. Stemming is used in information retrieval system like search engines. Like I will give you an example of Google. So if you are writing a sentence in your Google search and it contains playing, it contains working, it contains worked, it contains differently, it contains difference, everything will be converted into the stem first, then the search will take place. This is the search engines, or I will say the information retrieval system. It is used to determine domain vocabularies in domain analysis. So whenever you want to know about the perfect answer for a particular word, then you need to get the stem of it, means root of it, then only you can do the domain analysis of that particular word. This is the application. So now, okay, this is the code snippet for the stemming. We just saw it. Now the lemmatization. What is the lemmatization? Lemmatization is the same as the stemming, but the thing is, it links the words with the similar meaning. It links the word with the similar meaning, and then only it takes the step. Worst, it will link the worst with the bad. Worst is linked with the bad. Yes, this is the example. Lemmatization is similar to the stemming, but it brings contents to a word. It links words similar to the meaning to the word. Sometimes the problem with the stemming is that suppose rocks. This means multiple rocks. Multiple rocks. If you use stemming here, it will convert the rocks into rock. This means single rock. This means single rock. So therefore, the meaning got changed. Meaning got changed. But if you use the same with the lemmatization, rocks,
it will keep it as rocks only. The lemmatization will keep the rocks as rocks only. Because it checks the context, means meaning of the rocks, and then it will see if I convert it into the stem, the meaning is being changed, so I will not remove this s, I will keep this s. The lemmatization only converts if the meaning is not changing. The lemmatization only converts if the meaning has been not changed. Okay, let's see. So we are importing the wordnet lemmatizer from the NLTK.stem. Again, wordnet lemmatizer, it's a class. So we need to create object out of it. Then we need to download the wordnet. Wordnet has the billions of words present in it. So we need to download it so that it can compare from the wordnet. Then what I am writing rocks lemmatizers, that is this particular LEMM dot lemmatize. Lemmatize which word? Rocks. So if you see that it is converting rocks as rocks only. It is converting rocks as rocks only. It is not converting rocks as rock. If I do the same thing with the stemming, see here I am using the stemming here, ps.stem rocks, output I am getting the rock. Output I am getting as rock. What does that mean? It means that word lemmatization only changes the thing if the meaning is not changed. If the meaning is changing, it will not convert that particular word into a stem. Same thing is here. It is seeing that the rocks meaning is multiple rocks. If I convert this rocks into the rock, that means single rock. So the meaning is being changed. So I will not make the rocks as rock. I will keep the rocks as rocks only. Okay, but with the stemming, no. We can see by the help of this attribute as POS as A, we can see how lemmatizer is making or is linking the word. See here, if I'm trying to link better, it is telling me it's a good. It is linking the better with the good. I am passing the better here, it is telling me better is good. But if I do the same thing with the stemming, it is giving me better as better. Better as better. Same thing if I do like this, worst, the word lemmatizer, it's telling me worst is bad. The word lemmatizer or the lemmatizer, it will tell me it is a bad, worst is bad. Then I have the sentence. In the sentence, I have better, good, worst, bad. Now, can I use directly lemmatization? No. Okay, okay. POS means that positions. Positions means that what type of thing you are trying to link right now. Right now, I am using the A here means adjective. Okay, Deep? So this thing, after that, what I am trying to do, I have this sentence here. Can I use directly the lemmatization here? No, definitely not. I cannot use it. So what I will do, I need to first tokenize this sentence. So I am tokenizing this sentence. Now I'm getting this better, good, worst, and bad. Now I have the tokens with me. Now I can apply the stemming as well as lemmatization. So if I am using the stemming here, I am writing it as W, stem it to ps.w stem. So better stem to better, good stem to good, worst stem to worst, bad stem to bad. So nothing changed. But if I do the same thing, with the lemmatization, better goes changed to good, good got changed to good, worst got changed to bad, bad got changed to bad. So we converted the 4 entities into 2 entities only with the help of lemmatization. But with the help of stemming, the 4 entities are still 4 entities only. But here with the lemmatization, the 4 entities got changed into the 2 entities only. After that, let's take another example. If we check, can we use the lemmatization without a voice? Yes, you can use the lemmatization without voice. No issues. Even though we have used it. One second. Have we used it? Yes, here you can use. See, lem.lemmatization rocks, and here you are getting the output. Okay, this is clear. Okay, we reached here. Suppose we are taking our input as corpora. The corpora stem word is corpus. Corpora means different type of multiple corpuses. And see, we are getting the output also. Corpora got converted into the corpus. But if I apply the stemming, the corpora stays corpora only. The corpora stays corpora only. What does that mean? That means the stemming is not able to correlating different words. But as far as lemmatization is concerned, lemmatization compares this corpora with different words, and then it comes to the conclusion of corpus. That it came to the conclusion of the corpus. Okay. So are you coding in Python? Yes, we are coding in Python only. Yes, because in the machine learning, deep learning, data science, the Python is very much necessary. So we will keep the Python as our primary language right now. So if you join that first topic, you will learn regarding the Python for more than for 5 weeks. You will learn Python. Then you will learn machine learning based on Python. Then you will learn data science based on Python. Then you will learn deep learning based on Python. So Python will be our primary language as it's the most important language right now after the JavaScript. No issues. According to the according for the NLTK, this is the first lecture only, Dipesh. Okay, now let's see the POS tagging. It's a code snippet. Tagging parts of speech. Parts of speech means that whenever we try to learn a particular language, we need to learn about its grammar. It's very much necessary. In India currently, from wherever we are, if we are from Tamil, we are from Karnataka, we are from Delhi, we are from Mumbai, we are from Bengal, we are from JNK, we are from anywhere in the right now from anywhere in the India. Nobody's mother tongue is English. Only less population's mother tongue is English. But very rare it is. So every one of us has learned English language. That's why we are able to try to speak and try to write English fluently. Because from the childhood, we are learning about the English language. Why? Because it's the general world language. Now, what is the thing here? While we tried to learn about the English language, it was very much necessary for us to learn about the grammar out of it. If we don't know about the grammar of that particular English language or that particular language, we will not be able to speak. If I change my sentences grammar, you will not be able to understand what sir is speaking, what Ajay sir is speaking, what Ajay is speaking. Nobody will be understand if we will not speak based on the grammatical rules. Now we need to learn about the grammatical rules and how we can teach the grammatical rules to our machine learning model. And that is known as parts of speech tagging. Let's see. In the parts of speech tagging, the first thing we have is the text. This is my sentence here. Ajay, Mahesh, Saurabh are working together in InsideAIML. And then what we are doing here,
we are having here, we are doing the first step as word tokenization because it's necessary. We need to break firstly the word, then only we can apply other things. Okay, so we are having here word tokenization. Then we need to remove the stop words. Okay, so here we are removing the stop word. This is the same piece of logic I'm using. Now output I am getting Ajay, Mahesh, Saurabh working together inside AML. Then I am using the word limitization. In the word limitizer, I am getting Ajay as Ajay, comma as comma, Mahesh as Mahesh, Saurabh as Saurabh, working as working, together as together, inside AML as inside AML. So limitizer has not changed anything. It means limitizer has seen the context of that particular sentence, and based on the context, it has decided that if I make some changes, it will change the course of that particular sentence. But if we do the same thing with the stemming, see, stemming has changed. Ajay keeps Ajay, Mahesh is Mahesh, Saurabh as Saurabh, working becomes work, together becomes together. This is the problem. This is the problem with the stemming. Limitizer will take decision only if the sentence's meaning is not changing. But here, if we change working to work, the sentence whole context is getting changed. If we change the together is together, whole thing will be changed because it's not a word. This is the difference between the lemmatization and stemming. So if you are interviewer, if you are college professor, or if you are working in a job and your senior asks you what do you prefer, lemmatization or stemming, so definitely without the hesitation you should say that lemmatization. And if they ask for the explanation, if they ask why, what, on what basis you are giving this explanation, so that should be that. So the explanation should be like this. Explanation should be, sir, the stemming doesn't look according to the context of the sentence. It does whatever it wants. But sir, lemmatization, if we talk about the lemmatization first check the context of that particular sentence, and then only it makes some change. Okay, I hope it's clear. Now I am using post tagging here. Okay, I am using post tagged, and I am using the filtered sentence. Which filtered sentence? The sentence which I got here, this particular. After removing all the things, all the means, all the discrepancies of stop words. So I am downloading the average perceptron tagger. Means we are tagging each perceptron. A word is known as token, it is known as atom, it is known as perceptron also. Okay, so I am downloading firstly NLTK.download average perceptron tagger. Then I am making the object of POS tag. I am writing tagged is equivalent to NLTK.post tag, and what I am passing, this filtered sentence. Now I am checking this tagged variable. In the tagged variable, I am getting a list of tuples. So it is telling me that AIML is a noun, working, or Saurabh is again a noun pronoun. Again, Mahesh, it is a noun and belongs to the noun phrase. Ajay, it's a noun and belongs to the noun phrase. Working, it is a verb belonging to the BC. So we have tagged each elements in our list. In our sentence, we have tagged each thing. So this is how POS tagging works. Now you know each word's particular grammar also. Now it will be easy to understand us to follow further the processes. Now we can extract the information based on the grammar. Now we can extract the information easily based on the grammar. What are the informations we can extract based on the grammar? We can extract the information like phrases. What are the noun phrases available? What are the verb phrases available? What is the most important thing here? What is the entities present here? What we are talking, which subject we are talking right now?
So those are the things we can get. I hope guys you understood. So this is our NLTK first part. So tomorrow we are going to learn about the NLTK second part. Okay. So give me 1 second.